Hi, you're back with Andrew, and we're working on some statistics problems tonight. I'm working on a section of the book on variability, and the next item I have to work on is the standard deviation, and my homework problem has 20 scores in it. I'm going to use an online tool called cram101.com to help me do this problem. Cram's a lot easier than a spreadsheet because everything's already formatted and the formulas are there and so forth. So I'm going to cram101.com. This is the Stats Labs menu. We want to get down to variability and their standard deviation. Okay. So the first thing they ask is the number of scores in a problem. We have 20. And the first thing we'll need to do now is to enter those values. So we'll go 64, 48, 55, 68, 72, 59, 57, 61, 63, 60, 60, 43, 67, 70, 65, 55, 56, 64, 61, and finally 60. Okay, now there's our data into the data table. Just make sure we got everything where we want it. Okay. You can come back to Cram 101 anytime you like and hit random data. And it's really cool because it'll give you new values. You don't have to enter everything in, and you can keep practicing until you master the problems. Okay, so next thing we want to do is break our formula up. Let's just go back up to the top real quick. So we're going to take the standard deviation formula and then kind of break it apart into its components and solve each step, and then we'll come up with a standard deviation. So the first thing we want to look at is to start working on the numerator. So let's first get the sum of the scores. So if we go through our distribution and add them all up, our sum will be 1208. There we are, 1208. And then next we want to square each score and then sum those. So Cram will help us out with that too. We go back to the top of our distribution. We've squared each score. 64 squared is 4096, 48, 2304, and so forth. And then we sum that column to get the sum of the squared scores. So we have 73,894. There we are, 73,894. Now the next thing to do here would be to solve the right-hand side of our numerator. And we have the data and the values to do that. So let's proceed with that. That's step 3. So let's go, and we have the sum that we got in first place, 1208, which is the sum of all the scores. Square that, it gets us to 1,459,264. And we're going to divide that by the total number of scores in the distribution, which is 20. The result is 72,963.2. And then the next thing we want to do is to then solve for the entire numerator. Okay, let's solve for this piece here. And again, we have the values that we need to solve that. So let's click on that. So here's our 73,894, which we got when we summed each or squared each score and then summed those. So 73,894 is the left-hand side of the numerator, minus the right-hand side of the numerator, which we just found was 72,963.2. The difference of those two values gives us a value of 930.8. That's our numerator. Going back up to our formula, we now want to take our numerator divided by the denominator, which is n minus 1. Scrolling back down. Step 5, we'll click this. So we take our 930.8 and divide that by 19, which is the number of scores minus 1. 20 minus 1 is 19. And the result is 48.99. And then the final step to get to the standard deviation is to take the square root of step 5. Square root of 48.99 equals 7. So our standard deviation for this distribution is 7. Now I'd like to always get an idea what that distribution looks like, and this is optional. So we're going to look at a plot, so the first thing I'm going to do is put the data in numerical order. So we go from 43, 72, and then we need to choose a number of intervals. 20 data points is a little bit tough to look at, so we're going to reduce that to, let's just take 10 intervals, and that's arbitrary. You can choose any value you want. Again, our upper level is 72, our lower we said was 43. The difference between the two gets us the range of 29. Since we've picked 10 intervals, we divide 10 intervals into the 29 to get an interval size of 3 by rounding it up. And that gets us our 10 intervals. So we'll do a quick frequency count and go back to our data and plug into each bucket the number of scores that would satisfy that interval. And then we have a frequency count, and then we can now look at the plot. And there's our distribution, which has a standard deviation of 7. Thank you.